So this is the 2016 Leaving Cert Higher Level Paper 1 and we're looking at question number 4. Part A. Prove by induction that a to the power of n minus 1 is divisible by 7 for all n being an element of the set of natural numbers. Okay, so the first thing we're going to do is prove the case for the number 1. So if we put 1 in, we've got a to the power of 1 minus 1, and that's equal to 8 minus 1, which is 7, and that's divisible by 7. 7 is divisible by 7. So we've shown that it's true for the case of 1, for n equal to 1. So now we're going to look at the case for k. Okay, so we're going to assume that it's true for k. So we're going to assume that a to the power of k minus 1 is divisible by 7. Okay, so now we're going to look at the case for k plus 1. So that would be, if we replace the n with k plus 1, we've got a to the power of k plus 1 minus 1. Okay, so now what we want to do is try and involve our assumption that a to the power of k minus 1 is divisible by 7. So if we can get this involved, that would be good. So what we can do here is, if we have a look at our rules of indices, which I've taken here from the tables book, we have a look at the top rule here, this one. If we can use that rule in reverse here, for a to the power of k plus 1, we can change that to a to the power of k by a to the power of 1. And then we still have our minus 1 at the end. Okay, so that's equal to, I'll just write that backwards here, that's 8 times a to the power of k minus 1. Okay, now the trick here then is to split this 8, this first 8, into 7 plus 1. So it's still the same value. We've got a to the k on the outside still and minus 1. By introducing this 7 here now, because we're trying to prove that it's divisible by 7, we'll see what happens here. So when we multiply this out, when we multiply the a to the k by 7 and then the a to the k by 1, what we get is 7 bracket a to the k, and a to the k by 1 is just a to the k, and we still have our minus 1 at the end. And what we can see here then is that this term here is divisible by 7 because it's 7 times something. So this is divisible by 7. And a to the k minus 1 is divisible by 7 because of our assumption, because up here we assumed a to the k minus 1 is divisible by 7. So we can just say that's divisible from pk, our pk situation. So pk plus 1 is true when pk is true. So since p1 is true, then by induction for all natural numbers for all natural numbers greater than or equal to 1. So that's the proof. Okay, moving on, part B. Given that the log of 2 to the base a is equal to p and the log of 3 to the base a is equal to q, where a is positive, write each of the following in terms of p and q. Okay, so we want to, when we're going to manipulate these things here now, we're going to try and we're going to hope that we can get log of 2 to the base a involved and log of 3 to the base a involved. So here we can see, first of all, it's a good idea to have your rules of logs from the tables book beside you. So the first rule I'm going to be trying to apply here is this one. So if the log of x over y to the base a is equal to the log of x to the base a minus the log of y to the base a. So here x and y is 8 and 3, so that's going to be equal to the log to the base a of 8 minus the log to the base a of 3. Okay, so I can spot straight away, there's log of 3 to the base a, so that's q. And now here I'm in trouble because I have the 8, however I know that if I want to get 2 involved, I know that 8 is actually 2 cubed. So I can change this to the log of a of 2 cubed. 8 is just 2 cubed minus the log of 3 to the base a. And then using another rule of indices, which is this one here. So I use this rule of indices here. Now I can see that the power for this first bit, just if I use it on this one, the power, the 3 can come to the front, just like the power q came to the front here. So that's going to give me 3 log to the base a of 2 minus the log to the base a of 3. And finally then we can see that that's just going to give me 3 log of 2 to the base a. Well, the log of 2 to the base a is p, so that's just going to be 3p minus log of 3 to the base a, which is just q. So it's 3p minus q is my answer. So for part 2, the log of 9a squared over 16 to the base a. So what I'm going to do here is the first law I'm going to apply is going to be this one here in blue. So when I apply that law, it leaves me with the log of 9a squared to the base a minus the log of 16 to the base a. Okay, so from here then, that's going to be the log to the base a. Well, 9a squared is really just 3a all squared. And that's going to be log to the base a. Now 16, I'm trying to involve 2 or 3, but I know 16 is actually 2 to the power of 4. So I'm going to put that in there now. I'm going to change that 16 to 2 to the power of 4. And then here, I'm going to apply, now I'm going to apply the law in green here, just to this part. So when I do that, that's going to give me, the 2 will come down to the front, so it's going to be 2 times the log of 3a to the base a. And then that's going to be minus, and I'm going to apply the same law here to this one. So the 4 will come down to be 4 times the log of 2 to the base a. Okay, so now what I can do, if it's twice the log of 3a to the base a, I can now actually apply the first law of logs, which I'm going to show here, this law, I can apply that to this part here. So the log of xy to the base a is equal to the log of x to the base a plus the log of y to the base a. So the product of two things. So here I've got 3 by a, so I'm going to split them. Just leave the rule in view there. So that's going to be 2 times all of this, so it's going to be the log of 3 to the base a plus the log of a to the base a, and then it's still going to be minus 4 the log of 2 to the base a. Okay, so finally then, that's going to be equal to, well, the log of 3 to the base a, the log of 3 to the base a, that's q from up above, if you remember. The log of 3 to the base a is q, and the log of 2 to the base a is p. So I'm going to substitute them in now. So that's going to leave me with twice q. The log of a to the base a, well, the log of something to the base of it itself is 1. So that's going to be plus 1. And then minus 4 times the log of 2 to the base a, that's p. So now one final tidy up. I'm going to multiply the 2 by each of these, so that's going to be 2q plus 2 minus 4p. And now we have the answer in terms of p and q. And that is the end of question 4.